Today, continuing with our topic of mapping and function, we are going to look at some of the revision question. So we shall begin right away with number 1, which says, given a set with elements, that is 2, 4, 6, draw a parallelogram to show the relationship is the smallest prime factor of. Then we shall begin with our solution and see. Question 1 is saying, given the set that you want us to draw a parallelogram to show the relation is the smallest prime factor of. So we shall simply have our circle. This is question 1. They're saying you want us to show the relationship is the smallest prime factor of. So we are given 2, 4, and 6. So taking note of towards smallest prime factor. So under the prime numbers we are having in that set, we are having at least 2, which is a factor to both 4 and 6, whereas also it is a factor to each so they're saying smallest prime factor of. So taking note, don't forget the two aspects we have talked about as being the smallest prime factor of. So we shall take note of those keywords as we draw the parallelogram and see how best shall we go about this question. So this is our parallelogram we have drawn. So we have said 2 is the smallest prime factor of itself. Then we are having 4 and 6. So 2 is still is the smallest prime factor of 4. So we shall have to put there this arrow. Then still is the smallest prime factor of 6. So we are done with that question. Let us see how best we can continue and go on. So that is part A. We're done with part A. Then part B, for the mapping that, find the domain. So we are given the range and they want us to find the domain for part B. So if this is our domain and this is the range, so we're given elements in the range as 1, 13. Then we don't know what is in the domain, but we're given a mapping. This is our domain we are looking for. Then we're given this mapping, which is x for x plus 5. So taking note of this, we are looking for the domain. So using that same mapping they are given us, shall say f of x is given as x for x plus 5. But since now we're given the range, which is like our image, and we are looking for the domain, what shall we take? So we shall take the whole of this f of x to be 1, which will give us 4x plus 5. Yes. Then we shall collect like we shall make x the subject of the formula. So we simply take 5 this side, becomes 1 minus 5 equals to 4x. So we're having a 4 equaling to 4x. Our x will give us a 1. So alternatively, someone else can use another method, but let me just use this for simplicity, then we shall move on. Then we're having here 1. Then we're having still f of x giving us 4x plus 5. So taking 13 now, we shall have 13 equals to 4x plus 5. This will give us, we shall also make x the subject. So 13 minus 5 equaling to 4x. So we are having 13 minus 5, which is our 8, which will give us 4x. So dividing both sides by 4, we shall end up having 8 over 4, giving us 4x over 4. So our x will roughly give us a 2. So we are having here a 2. So if you want to prove for the first one, you shall just put here f of 1. So when you put 1 here, so we had 1, the domain. So we had here 1 minus 5, which was a negative 4. So our x was a negative 1. So if you want to prove, then we can put them back. This will be a negative 1, 4 times a 4 plus 5. You still come back to a 1. So we are done with that part. Then part C of the question, saying the function f of x is that, g of x is that. They're saying find the value of x such that f of x equals to g of x. So we're given that f of x equals to, you can see the question, f of x equals to 2x squared. Then they gave us that g of x equals to 5x minus 3. So our g of x equals to 5x minus 3. So they told us to find the value of x such that f of x equals to g of x. Simply shall just equate this. So we want to equate f of x equaling to g of x. So f of x is 2x squared equaling to g of x, which is 5x minus 3. So end up having 2x squared minus 5x. We are putting all this to the side, then plus 3 equals to 0. So what we have done is what we call arranging a quadratic equation. So you can use any method of solving a quadratic equation. So you can look at that, identify the product and sum. So when you look critically, this is always the sum. So our sum is negative 5. Then the product will be the coefficient on x squared times the constant here. So when we multiply this 2 times the 3, so we come to positive 6. So our factors we are looking for, the factors will be simply, first look at those numbers which you multiply to get 6, but when you add them, we get a negative 5 when we add those two factors. So look at the numbers you can multiply to get 6, but they should have the aspect when we add them come to negative 5. So first look at those numbers. When we multiply them, we get 6, which is 2 times 3, 6 times 1, they will still give us the 6. Then looking critically, the two factors will be 2 and 3, but since we have the aspect of a negative, shall have our factors as negative 2, negative 3, such that when we multiply them we come to a 6, and when we sum them up we come to negative 5. So let us see how best we can deal with this, and we see how we push on. So here we have 2x squared. So in place of negative 5, we shall put there the two factors we got, which is negative 2 and negative 3. So negative 2 and negative 3 shall have 2x minus 2x minus 3x, then plus a 3. This will give us a 0. So pulling out what is in common, shall pull out 2x. Here remain with the x minus 1. Then here we pull out a negative 3. We shall pull out a positive 3. So we shall have, when we pull out a negative 3, because we have to make sure that what is here will resemble what is here when you are factorizing out. So pulling out a negative 3, we remain with the x, then minus a 1 equals to a 0. So here, since these two brackets are the same, we shall take on 2x minus a 3 into x minus 1. This will give us a 0. So either 2x minus 3 equals to 0, or our x minus 1 equals to 0. So we have 2x will equal to 3. Our x will give us, divide both sides by 2. Here by 2 we have 3 over 2. Then still our x here will equal to a 1. So written critically, we have two values of x. Those are the values we have gotten for x. So that is the solution to question 1. Then question 2, they want us to, given that h of x is that, find the value of h of negative 2. Then let's find the value of x when h of x is 7. So simply how can we go about number 2? They're saying our h of x equals to 3x minus 2. Then they want h of negative 2. h of negative 2, we shall just substitute simply. Since h and h are the same, then we shall substitute for x as negative 2. So we have x times negative 2 minus 2. So this will give us negative 6 minus 2, which will bring us to negative 8. So we are done with h of negative 2. Then we want the value of x when h of x equals to 7. So value of x when h of x, that is Roman numeral number 2. This was Roman numeral number 1. So want the value of h of x, the value of x when h of x equals to 7. So our h of x was given as 3x minus 2. So we just substitute for h of x, which is 3x minus 2, so that we can easily get the value of x. This will equate to 7. They gave us here that h of x was this. So I have just replaced where there is h of x, I put there this. So let's look for the value of x by collecting like terms. This will be 3x, which shall take to the other side, becomes positive 7 plus 2. So we have 3x equals to 9. So dividing both sides by 3, our x will give us a 3. So we have found the value of x.